Okay, so today we will start with SQL Server database concepts. In previous session we talked a little bit, but I thought we will begin again. SQL Server instance. So as we talked, SQL Server can have one or multiple instances. In our installation, when we installed SQL Server 2016, we installed one instance of SQL Server onto our machine. Similarly, we can have multiple instances of SQL Server. So if you look at real-time applications or real-time projects, you will have different environments: development environment, test environment, production environment, like that. So each environment will have its own instance of SQL Server running. So you do the development and development environment, and then you do the testing in test environment. So development environment will have its own SQL Server, test environment will have its own SQL Server. Similarly, production, once you do the testing, you finish the testing, you move the code to production. So production will have again its own instance of SQL Server. So SQL Server will have multiple instances, and each instance consists of three things: relational engine, storage engine, SQL OS. So these are the key components of SQL Server for SQL Server to function. So what does a relational engine do? Relational engine is responsible for interpreting the queries. So when we write a query to pull the data or to do some activity on the server, relational engine interprets the queries or interprets our commands and performs the necessary action. Okay, that is the responsibility of relational engine. It is basically interprets the commands or our queries. Then storage engine is responsible for storing the data and retrieving the data. Let's say we issue a SQL statement to insert a specific record, insert a record to a table, right? So then relational engine understands that insert statement or understand that SQL statement and interprets into the SQL understanding format, and then storage engine will come into picture, that basically makes sure that the data gets into the table. Okay, then SQL OS. What is SQL OS? SQL OS is responsible for talking to the operating system. So when we run when we want to perform any activity on SQL Server, let's say we want to insert a data, or we want to extract some data, or we want to modify some data. So all these are activities. To perform each activity, SQL Server needs certain resources from operating system, right? Some certain amount of memory, certain amount of RAM or processor, core, all those things. So SQL OS is responsible to communicating to the operating system in getting the required resources. So those three, relational engine, storage engine, and the SQL OS, work together when we are issuing commands against SQL Server. So one is responsible to understand our commands, the other one is responsible for storing the data and retrieving the data depending on the commands, and then SQL OS is responsible for talking to the operating system and allocating the required resources. Okay, so those are the three components of SQL Server. And once we look into the SQL Server main components, the components I was talking earlier here are basically the ones who are at the core execution level. Whereas at the SQL Server, when we look at the SQL Server, we have these components like database, security, link servers, replication, management, SQL Server agent. There are a lot of other components which I haven't listed here, but these are mainly useful in terms of developer point of view. Okay, so what does databases hold? As it says, databases hold databases. Okay, So if you connect to our SQL Server, so to connect to the SQL Server, we need to go to Start and type SQL Server Management Studio. Okay, so I just go here and type SQL Server. Okay, it's already opening. SQL Server Management Studio. Okay, so it opens the SQL Server Management Studio, and then it opens connect to server window. Here you can connect to 4 different things: database engine, analysis services, reporting services, and integration services. You can access 4 services using this one, SQL Server Management Studio. So for here now we will connect to database engine. Select a database engine and select your machine name, click connect. So it will connect to the SQL Server on our local machine. Once you connect to the SQL Server, you see these components. Databases, right? So databases consists of all the databases in the server. It shows all the databases in the server, and these databases include system databases and user defined databases or user databases. What are system databases? System databases are created by the SQL Server when we install an instance. Okay, and the user databases are the databases that were basically created by the user for our application purposes. Okay, and then security. Security consists of logins and roles. Security is the area where we set the permissions to access the SQL Server. We set the permissions to access SQL Server. We set the permissions to access the data in the SQL Server. At the same time, we set the permissions to do manipulations on the data. So depending on the user level, you give either read access, write access, or no access. So depending on the user, you provide appropriate permissions to do certain activities. Okay, that is done through security. Security folder is here. If you look at security, we have multiple things: login, server roles, credentials, audits, and all. These are all related to security, but we will just look into logins. Logins is basically where you add the users. Okay, so as a developer, when you want to quickly check whether a specific user has permissions or not, you go to the login folder and look for the user. So these are all the users having access to my database. One of the users are the local account and local service account. So all the users will be listed here, whoever has the access. Okay, that is security. And then link servers. Link servers are basically responsible, or link servers are used to connect to remote servers. Let's say you want to execute a SQL statement, or you want to execute some command against a remote server, not on your local machine. This is your local machine, right? Let's say in your application you want to run something on remote server, the remote SQL server. So in that case you use link server. Link server is a concept where you connect to remote servers to execute a command. Okay, those are available under server object. If you go to server object, you will see link server here. Okay, then replication is a DBA term. Replication is basically to replicate data from one server to other, so we don't need to worry about that now. Then under management, so there are some components under management which basically perform different activities. The one of those is resource governor. Okay, resource governor. Resource governor is mainly responsible for allocating the resources. So when we are running a queries, or when we are running some commands, updating the data or executing some steps, SQL Server needs resources, right? So resource governor basically understands what kind of resources we need to perform certain activity, and depending on that it allocates the resources. So in this area you can also go and set the resources you need. So you can set the pool, resource pool, and you can configure it saying that I need so and so resources to perform so and so activity. Okay, again that is an administrative activity. I just wanted to um, bring it up here. And logs. Logs are basically transaction logs. Transaction logs, what are transaction logs? Transaction logs are the log information whenever you perform any activity except the select statement. Let's say you are inserting a record into a table or you are updating a record to a table. So when you do those activities, what SQL Server do? It basically not only does the change to the data. Let's say you are inserting a record to a table. Okay, so SQL Server inserts the record to the table. At the same time it logs that information saying that so and so user at so and so time inserted a record into a table. So that's a log activity. Similarly, let's say you are updating a record. So it updates the record and at the same time it logs that information to the system, saying to the log, saying that so and so user updated the record at so and so time. Okay, so that is log. And one more useful feature is database mail. Database mail is used for sending mails on the SQL Server. So you can use database mail to send mails from the SQL Server. Why do we use database mail on SQL Server? So let's say we are running some scheduled jobs overnight, and when the job fails we want to be notified so that we can take appropriate action immediately without we going and checking and finding out that the job failed. We can set up a notification mechanism where we can get notified by email as soon as there is a failure. That is a database mail. It's a feature available in SQL Server. Next we have SQL Server agent. So SQL Server agent consists of SQL Server agent jobs. So what is job? A job is an activity you want to perform in an automated manner on a given interval. So let's say you want to check the orders you received, or maybe you want to check uh, the space on the server. Let's put a simple example. You want to check if there is enough space on the server for the SQL Server. So because there will be transaction, data updates, modifications, data insertions, all these things, right? So SQL Server needs some space. So let's say you want to know whether there is a space or not on the server. You want to frequently check for the space on the server. If there is space constraints, you want to get notified. So the space checking for the space is a scheduled job, scheduled activity. You want to frequently do that. Every, let's say, 5 minutes you want to go and check for the space. So that is a scheduling. So you schedule a job or you create a job that does this space check, and then you schedule it to run at a specific frequency, for example 5 minutes. So what happens? SQL Server agent invokes that job and it performs whatever the steps you have. In our example it checks the space, and if there are any issues it basically notifies. So that is the job of SQL agent. SQL agent makes sure your jobs are invoked on a given interval as per your configurations. So if you look at the SQL Server Management Studio, you see something called SQL Server agent. So this is the place where you will see the jobs. By default SQL Server agent will be disabled. Okay, you need to enable and start the service. Okay, so all you need to do is right click here and say start. So once you say start, it will start the service. Click yes to confirm the service. So now SQL Server agent is running, the service is started. Right? If I expand this, you will see jobs. This is the place you will create the jobs that basically does certain activity, performs certain action. Okay. Apart from jobs, we have multiple other things which we don't need to worry at this moment. And there is something called job activity monitor. What does this do? This basically you can use to monitor the jobs. Let's say I click on this. So what does it show? It says what is the status of each job, whether it ran, succeeded, failed, all those things. So it just basically to monitor the jobs activity, what is going on with the SQL jobs. So that is about main components within the SQL Server. As I was saying, apart from these few, there are multiple other components, but mainly we need focus on these things as a developer. Okay. So we talked about databases. We saw that SQL Server has system databases and user defined databases. What are system databases? System databases are the ones that are created by SQL Server and used by SQL Server. We don't basically insert the data, or we don't use these databases to store any data. We use them to query, to check the system configurations or system health, but we don't modify the data in these databases. And then you have user databases. User databases are the databases that were created by users for our application purposes. Okay. So user databases are the databases where we insert the data, we manipulate the data, and we store the information, but we don't touch the system databases. SQL Server supports 32,767 user databases. So you can have a huge number of databases, and each database size can be around 500 terabytes, 524 or something terabytes. So SQL Server can grow very huge. Okay, it has potential to grow. Then we will talk a little bit about system databases. What does each system database does, and what does it responsible for? So master database. So if you look at system databases here, you see master database. So master database is responsible for maintaining the metadata of the databases. Metadata means what are all the databases are in the server, and what are the configuration or properties of the databases, like size of the database, how many file groups it has, when was it created. All that information is stored in master database. It is master database is metadata of the databases. Okay, master database holds metadata of databases. Then we have resource database. Okay, resource database is a hidden database you can't see in SQL Management Studio. Let's say if I go to my SQL Management Studio here, I cannot see the resource database, it is hidden. Okay, so you cannot see the resource database, but what is the purpose of resource database? It holds the definition of system objects. System objects in the sense system tables. So let's say we said master database, right? Master database consists of metadata of all DBs. How does it hold metadata of all DBs? In the form of system tables. It holds the data in the tables, right? So resource database basically internally holds the system objects. So it holds the system objects, but it shows the objects under master database. Okay, so the actual tables reside in resource DB, which is a hidden database. And then we have model database. Model DB is responsible to hold the template of a new database. Let's say I want to create one user database. right? So when I want to create a new database, how does SQL Server know what are the default settings to create a database, right? So those information is stored in model database. So that's why DBS, database administrators, what they do, they create a template in model database saying that whenever a user creates a database, create the database with these configurations, like where should the database stored, what drive it should be stored, how much space, default space should be allocated to the database. Those kind of things will basically defined in the model database as a template. Okay. Next we have TempDB. TempDB is a temporary database allocated for each user. Okay. So what does that mean? Whenever a user accesses the SQL Server creates, or whenever you connect to a SQL Server creates a session for us, session for the user. And when it creates the session for the user, it creates a tempdb. As I was saying, tempdb is for temporary storage. So when we are performing an insert operation or update operation, whatever the temporary activities SQL Server need to perform, it basically performs on tempdb. That means if it needs to store a data temporarily somewhere, it uses tempdb database. Okay. So if we go to our SQL Server Management Studio, we see tempdb here, right? Tempdb consists of temporary tables. So whenever I am doing some activity, if SQL Server needs to store data somewhere temporarily, it uses tempdb. And as soon as I disconnect the session, the tempdb will be destroyed. But we cannot see that in action because we are closing the connection. So as soon as our session ends, SQL Server destroys the tempdb. So whenever we want to store the data permanently, we should never be storing in tempdb. We should be never.
Hello?
Yes.
Hello? Hello?
Yeah, I can hear you. Hello. Can anybody hear me, or is everyone facing a problem with
I'm
voice?
not able to hear you anything.
How about others?
I can hear you clearly.
Okay. Okay. Two people are saying there is a voice breaking. Let's see. Maybe I will try to fix something. So tempdb is temporary database. As I was saying, as soon as we disconnect the session, tempdb is destroyed. Okay. Then the last one is msdb database. Okay. MSDB database maintains the data or metadata about SQL agent jobs. So we saw that SQL Server has SQL Server agent, which basically consists of SQL jobs that we schedule to run on a given frequency, right? So the metadata or the details of those jobs are stored in MSDB. MSDB just maintains the details of SQL Server jobs. It also maintains other details like database mail or SSIS package details and all, but mainly MSDB is responsible to maintain SQL Server agent jobs. Okay. So those are all the system databases. We have five system databases: master, resource DB, model DB, temp DB, and MSDB. Okay. Of those five databases, resource database is hidden. Okay, you cannot see in SQL Server the management studio. And temp DB is temporary. That means um, anytime you disconnect the session, your tempdb is destroyed. Okay. So next we talked about databases. We said there are system databases and there are user database. So and we also said that databases are used to store the data, right? So how does the data is stored in database, and how does we retrieve the data? What happens when we try to insert the data? What happens we read the data? A database mainly consists of two kinds of files. Again, the data is stored in the database in files. Okay, and the SQL and the databases consists of two kinds of files. One is a log file, one is called data files. A data file is the place where data is stored, the actual data, whereas log file is the place where the log information is stored. So as I was saying in earlier slide, SQL Server stores the logs, right? Where does the log information stored? It is stored in log files. Okay, so log files are having extension as .ldf. Log file extension is .ldf and data file extension is .mdf and .ndf. So what is the difference between .mdf and .ndf? .mdf and .ndf both represents data files, but when we create the database initially, the first data file is created using .mdf extension, and that is also called um, primary data file. Okay, so the file that is created with .mdf extension is called primary data file, and the files that are created with .ndf extension are called secondary databases. Okay, so this is called secondary. Oops. Secondary data files. Primary data file, secondary data file, but the purpose of both data files is same. They are used to store the data. Okay, but when we create the database, initially SQL Server creates the data file with .mdf extension, and this going forward on the ongoing purpose, whenever we are creating new data files, we create SQL Server creates .ndf files. Why do we need to create new data files? Okay, so what is the reason to create new data files? Let's see the SQL Management Studio to understand that. So if you go to SQL Management Studio, let's say I want to pick my user database, AdventureWorks. I go to the properties to see the database properties. Okay, so here if you go to files, this is the place you can see the files of the database. So as I was saying, the first file is .mdf file. The first data file SQL Server creates is .mdf, and I created the second data file that has extension, that got the extension of .ndf. I did not put .ndf as an extension. I just I just entered the name of the file here, and SQL Server assigned .ndf extension. Similarly, we have .ldf, which represents the log file. You can see the file type here. Rows data represents data file, whereas file type log represents the log file. Okay, so if you look at this one, these two are data files, and the last one is the log file. So the question I was asking is, why do we need to create multiple log files, right? Why can't I use one log file? What is the need to create multiple log file? So generally in a real-time scenario, you will have your SQL Server will have multiple drives, right? Let's say your drive, one of the drives is 100 GB. Each you have 10 drives, like your machine has C drive, D drive, E drive, F drive, right? Those drives in your laptop or in your desktop. Similarly, the servers will have many drives, like 6 7 drives, C D E F G H I J K, right? So each drive will have some capacity, 100 GB, 200 GB, 400 GB. So what DBA does, whenever he creates a database, he sets the file limit, size limit on the database, saying that I want the data file to grow to certain extent. So let's say if the data drive has 100 GB of space, total space, he doesn't want to exceed maybe 90 GB or 10 GB. He wants to just leave it as a buffer. Okay, so he says he configures this file saying that my .mdf file or my data file should not exceed 90 GB of space. So here in this example you see it is unlimited because it's a sample database and ours is a test machine. We basically set it as unlimited. That's a default setting, whereas the log file is set to limited to 200 some GB or 20 GB, I guess, right? So like that, in real time scenarios, database administration database administrator sets the size of the database, saying that it should not exceed more than whatever the size of the drive. So what happens if we insert more data than that specified size? Let's say the drive is the data file is specified as 90 GB as maximum growth. What happens if I am inserting the data that is more than 90 GB, that takes more than 90 GB space? Then the DBA comes and adds new data files as needed to accommodate the data. So that's why we get multiple data files. So when the DBA or database administrator creates multiple databases, they all get the extension of .ndf. Okay, so that is the reason why we have we get multiple data files. Similarly, you can see multiple log files as well. If the log file is taking lot of space and you don't have sufficient space on a drive, you create another log file and store it in a different drive. Okay, these are all basically administrative activities which you should be aware. You may not be performing all this, but you should be at least having understanding why we have multiple log files, multiple data files. Okay, and there is another concept called file group. Okay, so file group is basically a group of files, you can say. So the simple term is group of data files. A logical group of data files is called file group. So whenever we are creating data files, we can assign to a specific file group. So if you look at this picture here, so user database has the primary data file which is assigned to primary file group. This is the file group name. Okay, then the subsequent data files like data here, data.ndf, data.ndf are allocated to different file groups. So file group 1 and file group 2. Okay, so you allocate to different file groups. And why do we need to allocate data files to different file groups? It is advanced concepts, like you want to store a specific table in a specific file group, right? Let's say you have one big fact table and you want to store the data in a specific file. Otherwise, what does SQL Server do? SQL Server can allocate the data to any file in the database. In this example, this particular user database has 1 2 3 4 5 data files, right? If let's say you are inserting a record into a table, that data can go into any file group. By default it goes to primary file group, but you can specify it to go to any file group. When you specify to go to file group 1, what happens? All the data goes into these dot files or this data files. Okay, so that is the main purpose of file groups, to allocate the data to be directed to a specific file. Okay, and similarly you have transaction log. Transaction log is .ldf file. So those are the main two files database consists of. Whenever we are storing the data, all the data goes into log files, data files, and all the log information goes into the log file. Okay. And next we have schema. So what is schema? Schema can be thought of a container of objects. That means, let's say you have two different OLTP systems. One is order system, other is sales system. Okay, orders system consists of certain number of tables, and whereas sales system consists of certain number of tables, right? So you want to segregate these tables. If you don't segregate, what happens? They will be mixed up, right? You cannot distinguish which table is belongs to sales, which table belongs to orders. So if you want to segregate the tables, you use the schema. Basically you are logically grouping the tables by a schema. So in this example here we have two different systems, sales system and HR system, right? So if let's say sales system has 10 tables and HR system has another 15 tables, if let's say you don't specify a schema, what happens? By default all the tables will be assigned to DBO schema. That is the default schema SQL Server uses. So that's why if you go to SQL Management Studio, you will see all the tables having DBO as the schema. DBO is the default schema used by SQL Server. But here let's say these tables, some of the tables are related to finance, some of the tables are related to sales, right? Fact reseller sales is the sales table, fact finance is the finance related table, and similarly you can find a call center. Call center is like a HR related, human resource related table, right? Since all the tables are assigned to the DBO schema, what is happening? All are mixed up here. Unless I look at the table name, I cannot understand what is this particular table belongs to, which feature, which functionality this table belongs to, right? Instead, if you use schema like here, if let's say I use sales schema and HR schema, what happens? Instead of having DBO as a default schema, all the tables will be having their appropriate schemas assigned to them. So sales related tables will all have sales dot table name. Instead of DBO dot, they will have sales dot HR dot. So in that case, what happens? It becomes very easy to understand or identify a table to a specific business functionality. So you can access a table by using that specific schema on the table, and it becomes easy to identify the table. It is not only for identification purpose, it is also for securing the table. So for example, here we have two systems in the database, sales system or a sales data, HR data, right? So HR data should be accessible to HR department, sales data should be accessible to finance department, right? So HR team does not need to know sales information. Similarly, sales team does not need to know what is going in HR, so they don't need to access HR data. So what we
Hello.
can do by specifying this schemas,
Hello.
yes,
Hello.
yeah, any question? I can hear you. Okay, so we'll continue. So if we create the tables with a specific schema, it will be easy to restrict the access. So you can say that the tables that with the sales schema should be accessed only by sales department users. Similarly, the tables or the tables with HR schema should be accessible only by HR team. That you can specify by defining the schema. Okay. So far we were talking about databases. As I was saying, database is a collection of permanently stored data. That is important. It is a permanently stored data. So database consists of permanently stored data, not a temporary. Okay. How does we store the permanent data? In the data files. So SQL Server uses the data files to store the data permanently and contains logically related data. So that we will see how it contains logical related data. So what is logically related data? In the sense, a sales related, all the sales related tables exist in one table, and when we say sales related tables, all the tables in that sales database are related, they are logically related. Okay. Now we will see the difference between DBMS and RDBMS. What is DBMS and what is RDBMS? DBMS stands for Database Management System. Database Management System is used for, again, creating the databases and storing the information, but the tables within the database may not be logically related. That means unless you look at the data manually, you cannot know that the tables are related. For example, in this picture here, we have bunch of tables: user profile, users, user roles, user relationship preferences, and user relationships. Right? There are around 5 tables here. Unless I go and look into the tables data, I don't know whether these tables are related, right? So the table names may be specifying the relation, like user profile, you can say that user profile is related to users. Okay, but let's say user profile table is XYZ and the users table is ABC. XYZ and ABC table. So if you have XYZ and ABC tables, how do you know that these two tables are related? Right? You cannot know, or you won't know until you go into the data and see what kind of data that those tables have. Right? That is older DBMS systems, database management systems. So yes, screenshot is not clear, I know, because I wanted to garble those columns. So it's by default. Even for me, it's not clear. Don't worry. Okay. So the tables, unless we go into the data, we cannot basically know that these tables are related or the data is related. That is the caveat in or drawback in database management system. But in case of uh, uh, relational database management system, what happens? The tables within the database are logically related. So when the tables are logically related, what happens? We can see the relation between the tables. So for example, in this case, let's say now, okay, now we have defined the relationships between the tables. This is called entity relationships. Entity relationships are entity nothing but entity is a table. Entity relationships are relationship between the tables. Okay. So now we have defined the relationships between the tables. Okay. So if you look at this table, you can say user profile table maps to users table by this relation, right. The moment you see this relation, you know exactly that these two tables are related. Similarly, user relationship preference is related to users table, but user relationships preferences table is not related to this guy, user profile, right. From the relationship diagram or by the relationships, you can clearly see or clearly tell that these tables are related, right. So that is relational database management system. In relational database management system, the tables are logically related, and you use the logical relationships to show the relationship between the tables. So in this case, these are primary key and foreign key relationships. We will talk about those later, but they are related. So that is uh, what you call relational database management system. Now a table. So we were talking about tables all the time. Database consists of tables. What does tables do? Tables are basically used to store the data, right? And tables consists of rows and columns. Okay, a table is an entity. Entity is a term used in database terminology. Okay, when you talk about relationships and all, you use entity. And table is basically an entity made up of rows and columns. A table consists of rows and columns. Okay, and column is nothing but an attribute of an entity that a table represents. That means it's a property of an entity. For example, in this picture here, you have employee table, right. Employee is the table, that is an entity, and the columns employee number, employee manager number, department number, job code, last name, all these are the attributes of the employee. So attributes are nothing but columns. So these are all columns, column 1 2 3 4. And then rows. Rows are the instance of all the columns of a table. Instance means, in this case, this is the employee table. That means this particular entity or this particular table, employee table, consists of information about an employee, right. And the columns consists of properties or attributes of an employee. So employee number, job, employee's name, first name, last name, department number, all these are attributes of an employee. Okay, and then we have the row. Row is an instance of all the columns or instance of all the attributes of an employee. So for example, the first row 1006, 1006 is an employee instance. So this particular row, this first row specifies one employee, right, which is Steen and John. So in theory, this table will not have any other instance that is similar to this particular this first row. That means the combination of all these columns will not be repeated in this table. That is in relational terms. In relational database terms, one instance of a row or one instance of all the columns will be occurring only once. There will be single occurrence of an entity in a table. Okay, that means and a single occurrence means the combination of all the columns. That means employee number 106, manager 1019, department number 309, job code, the same last name, the same first name, that kind of record or row does not or will not exist in this table again. So there will be only one instance of this entity. Okay. So this is these are all again in relational terms. Okay. So the table is basically an entity that consists of columns and rows, and a column is an attribute of the table. Attribute is nothing but it gives the properties of that entity. So employee number is one attribute or one property of employee. Manager is manager name or manager number is one attribute or property of employee, right? Job code, last name, first name, these are all attributes or properties of an employee. Okay, and a row represents a single instance of all attributes. That means the first row here represents one employee of one employee, that is 1006, and the combination of all these attributes. Okay. So that is basically about tables, columns and rows. Now we will talk about card rules. So card rules are not they are important, but I just want to say that you just need to be aware that there are something called card rules. So when you are talking about SQL Server, you need to be aware that there are card rules. Okay. So what are card rules? Card is basically a name of a person who defined 12 rules. Okay, for a database to be called a relational database. So we talked in earlier slides that there is a DBMS, database management system, and there is something called relational database management system. So we said that a relational database management system will become relational when we define relationships between the tables, right? But that is not just the only criteria to call a DBMS or database management system as relational database management system. There are 12 card rules that should be followed. Okay, so we'll just quickly go through all those rules. Rule 0. Rule 0 is nothing but the basic rule. So this rule states that system to qualify as an RDBMS, it must be able to manage database entirely through relational capabilities. That means all the tables in that database should be relational, should be connected together. That means they should be logically related, or they should have relationships between among the tables. Okay. That is the basic rule. And then rule 1, information rule. Information rule means all information is to be represented as stored data in cells of the table. That means all the data should be stored, all the information should be stored in cells, like cell, this is a one cell, right? Similarly 1019, this is another cell. So all the data should be stored in a cell. Oops. Give me 1 second. All the data should be stored in cell. Okay. Then guaranteed access. Each unique piece of data should be accessible by table name or primary key or attribute key. That means each cell in the table should be accessible by using the table name and the column name. So for example, if I want to know what are the job codes in this table, or what are all the names in this employee table, I should be able to get this information by using table name, which is employee, and the column name, which is first name. When I say get me all the first name from employee, I should be getting all this data, all the columns, first name columns. That is guaranteed access. Then systematic treatment of null. So null, SQL Server has something called null. Like any other language, null represents nothing. So when you want to represent nothing, we use null, right? So In other languages, null is always nothing. That means there is no value. But in SQL Server also, if you look at null explicitly, null by itself represents nothing. It just there is no value. But if you look at in the data terms, a null represents multiple things. Okay. For example, let's say this table had a column called middle name. Okay. We have last name, first name, and middle name. Okay. So let's say the middle name column is null. Okay, middle name column for one of the record for let's say Steen John middle name is null. So what does that mean? That means many things. Either Steen John does not have a middle name, or we don't know the Steen John's middle name, or we haven't yet loaded that value into the table. Right, there are multiple interpretations to null. So when we say null, it means many things. Either the data is not there, or we don't know the data, or we haven't yet loaded the data. Right. So that's what the third rule talks about. Systematic treatment of null. So null has several meanings. It can mean missing data. That means we haven't loaded the data, or data is not applicable. So in this case, maybe that person doesn't have a middle name, or it has no value. Okay. So the treatment of null should be handled consistently. That means when I say null in a one table, when I say null means one thing in a table, that should be consistent across all the tables in that table, in that database. Okay. So that is systematic treatment of null. Then rule 4, active online catalog. A database dictionary or database catalog must have description of database. Catalog to be governed by same or rest of the database. So what does that mean? So you should have a mechanism to access the description of a database. Description of a database means the metadata of the database. So we talked about master DB, right? Master DB holds the metadata of database. So what does that DB gives? It gives what is the size of the DB, what does the database consist, all those things. So that's what the rule 4 says. Database dictionary should be accessible. And rule 5 is the comprehensive data sublanguage rule. So the system must support at least one relational language. So to query the data, we are using database to store the data, right? So there should be at least one language to retrieve the data or to access the data. So the relational DB system should support at least one language. So SQL Server supports T-SQL, Oracle supports PL/SQL. Like that, database system should support at least one language. Okay. Then rule 6, view updation rule. All view that are theoretically updatable should be updatable by the system. So that means when you are updating a table or when you are updating a view is nothing but what you see in the query, right? So when that view is updatable, it should be updatable by the system. That is view updation rule. That means you should be able to update the data, in other words. Rule 7, relational level operation. So there must be insert, delete, update operations at each level of relations. Set operations like union, intersection, and minus should also be supported. So in other words, it says there should be a mechanism to insert or manipulate the data. Let's put it this way. So there should be a mechanism to modify or manipulate the data. So how do you manipulate? You either insert, you delete, or update the data, right? So relational database systems should support all these operations. Okay. Physical data independence. Physical storage of data should not matter to the system. So that means it doesn't matter where the files are stored. So we saw that a database consists of data files and log files. Within the data files, database can have multiple data files, right? So it should not matter where the files are stored physically, in which drive they are stored. Wherever the files are stored, when you query the data should be accessible. That means the storage of the files should not affect your application or should not affect your application. Yeah. So the data should be accessible irrespective of where we store the data files. Okay. Then rule 9, logical data independence. If there is a change in logical structure or table structure of the database, the view of the data should not change. So that means, let's say if there is a table in the database and it is growing in widely, that means that we are adding more columns. So since there are more columns in the table, we split the tables into two halves. So 10 columns in one table and 10 columns in other table, right? So though you are splitting the table, the user's experience should not change. That means when I want to look at the information of an employee, irrespective of how many tables you are maintaining for employee, you should be able to show that as one view. Like when I say show me the information of employee, you should be able to show all the information of that employee, irrespective of all the data is one table or in multiple tables. Okay, that is logical data independence. Then rule 10 is integrity independence. Integrity independence means the database should be able to enforce its own integrity rather than using other programs. That means you should not have integrity in the sense the tables within the data. For example, employee table, right? Let's say there is an employee table and employee vacation table, two tables. Okay, employee table will have employee information. Employee vacation table will have what are the vacations that employee took and all those things, right? So there is a relation. The employee vacation table should consist only the employee's information that exists in employee table, right? If there is an employee who is taking a vacation, that employee must exist in employee table, because employee table is the master, employee vacation is the secondary table. So that is what the integrity. Integrity means the tables, the data should be there should be integrity enforced within the tables data. If there is an employee who is taking a vacation, that employee record must exist in employee table. Okay? That is integrity. And to maintain that kind of integrity, what it says, we should not have the dependency on other programs. Like you should not be using some third party tools or some other things to enforce this integrity. SQL Server or any database system should have the integrity constraints inbuilt. Okay, so that is what integrity independence. So we will talk about all these technical things later. This is all just the rules. We'll just understand what they mean. Okay, distribution independence. A database should work properly regardless of its distribution across the network. So again, the database, even if you are distributing across servers, it should be working the same way. That means a database staying in one server versus the same database distributed across network should behave same way. Okay, non-subversion rule. If low level access is allowed to a system, it should not be allowed to subvert or bypass integrity rule to change the data. This can be achieved by some sort of locking or encryption. So what does it do? It says the low level access is allowed to a system, it should not be able to bypass the integrity rule. So if let's say we are allowing some other applications to access this data, they should not be able to bypass the integrity rules. So let's say there is some UI or some front end application accessing the employee details. So that front end application should not be interpreting or interrupting the integrity of the database. So that should not be allowed. So when the integrity is defined and integrity is set up within the database, the outside applications cannot break that integrity. That's what it says. Okay. So those are card rules very quickly. So I just wanted to explain those so that you are aware of the card rules. Okay. So now we will talk about normalization. Normalization is an important concept in terms of SQL Server database. Okay. So what does normalization do? Normalization is a process of reducing a complex data structure into a simple stable structures. So that means mainly normalization deals with reducing the redundancy in the table and reducing the complexity of the tables. Okay. So we will take one example. There are around 5 normalization rules. Today we will talk about 3 normalization forms. The fourth and fifth are basically advanced, they come later. Okay. So we will to understand the normalization rules, we will take one table and we will go through each normalization form and see how the normalization rules will help us simplify this structure. Okay. So for this exercise I am taking employee table. So if you look at the employee table, we have columns like employee ID, first name, last name, middle name, office ID, that means the office details where the employee works, and then the office location details, where the office is located, and the children information. Right. So we have 3 kinds of data here: children information, employees details, employee name, last name, first name, middle name, and the office they work or their work location. Right. We have 3 kinds of information here, and all this data is in one table. Okay, this is how we generally write in a database system. When we talk about an employee and when we have all these details, what do? We put everything in one table. Okay. Now we will apply normalization rules on top of this table. The first normalization form. What does first normalization form say? It says that each and every attribute within an entity instance has one and only one value. So no repeating groups. That means if there are any repeating groups, take them out as a separate table. So what is a repeating group in this table? If you look at this values, the last child information, right? These are repeating groups. And if you look at this child data, we have child 1, child 2, child 3 as columns. What if a person has 4 children? Right? If a person has 4 children, we cannot accommodate that information into this table because we have only 3 columns for children. That is one problem we have here. Similarly, the other thing is for a record or for an employee like 103 ID, we don't have any kids, right? All the values are null. That means that particular employee doesn't have any kids. Though that employee doesn't have any kids, since we are going with this structure, repeating groups, we are basically wasting all this space, right? All these cells are wasted. This space is wasted. We are not storing anything. We don't have anything information stored, but we are allocating space. So these are all called repeating groups. So what does normalization form say? Take out all the repeating groups and move it as a separate table or entity. So let's say if you follow the first normal form, what happens? We will take out employee table till the state, right? We call it as employee, and then we take the children information out of the table. Okay. Now these are 2 different tables. Now as I was saying, this particular structure does not suffice our needs. So if an employee has 4 children, we cannot accommodate. if an employee doesn't have any children, we are wasting space by just allocating cells there. So instead we will unpivot this data and make it like this. Okay, so we changed the data as employee children and we made two columns, employee ID and child name. So when we make employee ID and child, what happens? We can allocate as many kids as we want. Let's say one employee has 4 kids, we can allocate, there will be 4 rows. And if an employee doesn't have any kids, we don't need to put that record here. So for example, in this case, a couple of employees don't have kids, so those records are not coming into this table. So what is happening with this structure? We avoided repetitive groups. At the same time, we are enabling the efficiency, we are improving the efficiency. We are storing only the space that is needed, and also we can expand depending on the needs. Okay, that is the first normal form. Once we follow the first normal form, we can avoid the repeating groups. Then we talk about second normal form. Second normal form says it should be following the first normal form. The entity must conform to the first normal form, and every non-key attribute within an entity is fully dependent on entire key. Entire key is nothing but a key that represents the entire record, or we call it as primary key. A primary key or entire key is, or we sometimes call it as whole key as well. That key is basically, a key is nothing but a column that represents the whole record. So for example, employee ID 101 represents this whole record, right, and 103 represents this whole record, right. So employee ID is a primary key or a whole key or the entire key. Okay, so what does it say? All the columns in this table should be depending only on the primary key or only on this whole key, not any other keys. Okay, but if you look at this data, we have employee information and we have office location information, whereas this office location information is not depending on this guy, employee. So employee 1 doesn't mean downtown, right, whereas this office location information is depending on office ID. That means office ID 990 means it is a downtown office. Similarly, 991 means some other location. So here we have two employees working in same office. So this office location and office location details are not depending on employee ID. They are depending on the other non-key column. The non-key column here is office ID, right. This office details or office location information is depending on office ID, not on employee ID. So the second normalization form says take out all non-dependent columns. Any column or any data that is not directly depending on the primary key or the entity key, entire key, take them out. Okay, so if you follow the second normal form, what happens? We will still have employee children as is, and then we split the table into two parts. One is the employee table that will have only employee ID, first name, last name, middle name and office. So this information or this data represents the employee, right. All the other office location details are, they don't represent the employee. Okay, so we are separating that into a different entity. Okay, now we have taken out office details outside of employee. Now we will name that column as office location, and for office location, office ID will become the entire key or primary key. Now if you look at this data, the employee first name, last name, middle name, office ID are these are all represents employee ID 101. Similarly, this downtown and Bellevue, this office location information represents office ID 990. Similarly, this record represents office ID 992. So now all these values depend on this guy, the primary key. So that is the third normal form. So once we followed third normal form, what happened? We further split the data into two parts, and we normalized the data even further. Okay. Now we will see the third normal form. What happens in the third normal form? Third normal form also says entity must adhere to the second normal form, first and second. So entity should be already following first and normal, or should be conforming to first and normal forms. In addition, no non-key attributes within an entity is functionally depend upon another non-key attributes. It is similar to second normal form, but it says to further segregate the data. So if the data is depending, or if any of the columns are depending on the non-key attributes, then move them out. Okay. So again, if you look at this data closely, what we can do, what we can see here is we have office ID, office location, office phone number, postal code, office city, office state. If you look at these two columns, office city and office state, they are not depending on office ID. Okay, because 991 office and 993 office both are in Redmond, but at different locations. Okay, so Redmond doesn't mean office ID 991, or office ID doesn't mean Redmond, right? These two are two different things. Whereas Redmond means zip code 98052, or 98052 means Redmond, right? So this office city and office state information are depending on postal code, that is, which is the non-key attribute, or we can call it as descriptor attribute. Okay. So these two columns are not depending on the key, they are depending on another non-key attribute. So the third normal form says if you see that kind of information, you further split the table. Okay, split the data. So if you follow the third normal form, what happens? Again we will have the employee children, right, and then we will have employee table, and the office location we will split into two parts. One is office location, which will have only till postal code, and the other table with the geography information, we call it as geography. Now what is happening here, if you compare these two non third formal form and third before and after effects, for the Redmond 991 office, which is in Redmond, and 993 office, which is in Redmond, we are maintaining duplicate rows here, right, duplicate information in two cells. So unnecessarily we are wasting space by storing Redmond and Redmond in two cells, two rows, whereas both represents the same city. Whereas if you go to the normalize after effect, what happened? We are not wasting the space here. See, there is only one record for Redmond, and that particular record is being used twice here, right? So this one 98052, which is office 991, and 993 also 98052, and the mapping is in the geography table. So what did we do here? By following these three normalization forms, three normal forms. One is we avoided redundancy. Okay, the second thing what we did, we achieved the key dependency. That means the non-key columns or the descriptor columns are all depending on key column now. So if you look at employee table, all the first name, last name, middle name, office, all are depending on employee ID. Similarly, if you go to office location, phone number, postal code, these are all related to office ID. Right? Similarly, geography, office state and office city are related to the postal code. And we normalized children also by removing redundant groups. So that is basically the advantage of following normalization forms. These are three normal forms. We saw how they affect the design of the system. So when we are working on database systems, we follow these rules. So when we follow these rules, we basically come up with this kind of a structure where the the descriptor columns are nothing but the columns that describe the entity. In this case, employee first name, last name, middle name, they describe an employee, right? That's why they are called descriptor columns. Similarly, office location, downtown, phone number, postal code, these things describe the office. Okay, so that is descriptor columns. So non-key descriptor columns are all now depending on key columns. Okay, and fourth and fifth normal forms, as I was saying, they deal with multi-valued facts. That means many to many relationships and those things which we will talk later. Okay, so basically we need to be aware of first three normal forms. Those are the ones we frequently use. Whereas in warehouse systems, what happens, this is the way we are basically splitting the tables, right? We split one table into four different tables and we achieved a normalization. But in terms of warehouse systems or business intelligence systems, the main criteria for your success is achieving faster query results, right? It's reporting systems are always about querying the data, retrieving the data faster. So in data warehouse applications or business intelligence applications, what we do, we introduce the redundancy, that is called controlled introduction of redundancy. That means though there are four tables here and these four tables are adhering to the normal forms, what we do, we are okay with introduction of redundancy. So when we introduce redundancy, what we do, we combine these four tables into maybe two tables, so that we can query the data faster, because when the data is in one table, it is faster to query the data. Whereas if the data is in two different tables, SQL Server basically stores those information in two different pages, two different files, right? So when you are querying the data, it takes time for SQL Server to retrieve from two tables and then join those two tables, show it as one. So what we do, we introduce the control redundancy. We say it is okay to club these two tables into one, so that we can query the data faster. And how do we introduce in redundancy? Depending on our business requirements. So let's say if users are mostly interested in employee and employee children information and they frequently query on employee and employee children information, maybe you can club these two tables, employee table and employee children, into one, though there is a redundancy. Okay. Similarly, if business is interested in office and their geography information, you can club these two together, or maybe employee and their geography information. So depending on the user query or user requirement, you introduce the redundancy, control introduction of redundancy, and that is called denormalization. Denormalization is the process where we introduce the redundancy, controlled introduction of redundancy. So when you introduce redundancy, it doesn't mean that we just put everything in one table and we call it good. No, that's not what it means. It's a controlled introduction depending on only the user business requirements. So how do we achieve the denormalization? By following dimensional modeling. Dimensional modeling is nothing but is the technique to organize the tables or organize the information into dimensions and fact. So we will talk about that later when we talk about data warehouse. Okay. So we talked about chord rules, we talked about normalization rules. Now we will talk about acid rules. Okay. Today I am going to take 5 more minutes because I want to finish this thing. So acid rules are nothing but the rules that applies to a transaction. So this is also, you just need to be aware that there are acid rules. Okay. So acid rules applies to transaction. They are not applicable to the warehouse systems. That means we don't do transactions. We don't create transaction in warehouse. If you are doing transaction in warehouse, this applies to warehouse systems as well, or BI applications. So what is ACID rule? A stands for atomicity. Atomicity means a transaction must be an atomic unit of work. Either all of its data should be modified or none. That means if you are updating a order, let's say you placed an order and you are updating order quantity, right? So when you are updating an order, all of the information should be updated, either none. So or let's say you are updating an address, right? So all of your address including street address, all city zip code, everything should be updated. You should not say like I update half of the information and half not. So that is called atomicity. So a transaction must act as atomic unit of work. Everything should be applied or nothing should be applied. Okay. Consistency. When completed, or when a transaction is completed, it should live in a consistent state. So all the relational database, in a relational database, all rules must be applied to transaction modification. So what does that means? Once a transaction is committed, that means once an order is updated, the after effect should be consistent. That means whenever I see at that particular order, I should be getting same information, whatever the updated information. Okay. Then isolation. I stands for isolation. Isolation is modifications made by concurrent transactions must be isolated from the modifications made by any other concurrent transaction. That means if let's say there are two transactions happening on a same record, so order may not be an example here because only one person updates an order, but let's say there is a transaction where two systems are updating that same record. Okay. So when two systems are updating the same record, there should be updated in two isolated as a two isolated transactions. So they should not be updated as one transaction. So whoever issues the first update should be updated as one transaction, then the second system that issued that particular transaction should be updated. So we should not club both transactions into one and do the modifications. That is the isolation. So given transaction, if there are multiple concurrent transactions happening on the same record, those transactions should be applied in isolated manner, one after the other, not all together. Okay. Then durability. Durability is after a transaction has completed, its effects are permanently in the place. So permanently means even if the system fails, you should not lose the data. So that is the durability. Once the transaction is applied, once the data is modified, that effect should be permanent even in case of system failures. Okay. Those are acid rules at very high level. So next is I just wanted to give how the SQL Server going uh, in the market outside. So that is called ABC flavors. ABC is appliance, box and cloud. This is how SQL Server is available right now, as an appliance, as a box, as a cloud. So appliance is nothing but uh, Microsoft is giving like a whole appliance. Let's say you buy a fridge, right? When you buy a fridge, what happens? You get all the trays, all the boxes, everything inside it, right? You don't just get the outside box and all. So that is appliance, like an appliance. So when you buy a PDW system, PDW is parallel data warehouse, or it is called now ADW. Okay. So when you no PDW, when you buy a PDW system, what happens? Microsoft gives the hardware, software, operating system, everything together bundled up. So you are getting everything as a whole. That is called appliance. Boxing means now how the uh, Microsoft or any companies are selling. Boxing means you buy the software. You buy SQL Server as its own software, right? So you buy Windows as its own software. You install Windows and you buy SQL Server and then you apply SQL Server. So that is boxed. Then cloud based solution. So Microsoft is coming has come up with Azure, which is a cloud based solution for SQL Server. So these are the three ways a SQL Server is available currently: appliance, like a box, like a cloud. So depending on the application you are working, your SQL Server varies. Sometimes you may be working on cloud, sometimes you may be working on a boxed SQL Server or appliance. Okay. So that is a quick introduction of SQL Server database concepts. So I wanted to cover all the topics so that we can move on to the next one.